Okay, now we're going to put it all together and graph some of these rational functions. What we need to remember is that we're going to refer to them in this format like your book does, okay, where v of x is the rational function. Okay, to find the y-intercept of a rational function, all we have to do is find v at 0. Plug 0 into your function, find that out. To find the zeros, we'll need to solve for x when v of x equals 0. So you set the function equal to 0 and solve, which, by the way, will result in just setting p of x equal to 0, setting the numerator equal to 0. To find the vertical asymptotes, we'll solve for x when the denominator equals 0. To find the horizontal asymptotes, we'll use our rules, okay? Then we need to check to see if it crosses our horizontal asymptote anywhere. And then we might need to find a couple other values on the graph to help us piece it in. But we'll use some logic to help us piece together these graphs. Okay, so here we go. Example. We want to graph this. So the first thing we do is find our y-intercept. Okay, we can find that by taking f at 0. So in this case it would be 2 over 0 minus 4, which ends up equaling negative 1/2. So we know here that negative 1/2 is our y-intercept. 2. If we want to find our zeros, we set our function equal to 0. 0 equals 2 over x minus 4. And in this case, if we multiply both sides by x minus 4, we get 0 equals 2. Okay, and that doesn't make sense. So what we can say here is this one has no x-intercepts, which actually will help us later on. Okay? 3. We want to find our vertical asymptotes. We find our vertical asymptotes by setting the denominator equal to 0. So in this case, 0 equals x minus 4, or x equals 4. Now that tells me that I have a vertical asymptote right here at x equals 4. Remember, the graph cannot cross a vertical asymptote. 4. We find our horizontal asymptote using our rules. Here our numerator has a degree of 0 and the bottom has a degree of 1. So it's going to increase faster with large numbers on the bottom, making the ratio go to 0. So we have a horizontal asymptote here at y equals 0. Okay, now the fifth one is to check to see if it crosses. Does it cross the horizontal asymptote? And the answer is no here. We know this because we've already set our function equal to it. When we found our x-intercepts, it doesn't have any x-intercepts. Now, because of that, since the graph doesn't have any x-intercepts and our horizontal asymptote is the x-axis, it doesn't cross the horizontal asymptote. And if we know that, then we know a couple things. As a graph gets closer to a vertical asymptote, it must approach positive or negative infinity. Well, this graph must go down, and it can't go up, because if it went up, notice it would cross the x-axis, which we just said it can't do. So it has to do that, and then the whole point of a horizontal asymptote is it shows you where the function, what the function gets closer to as it goes out towards infinity. So we know that this graph has to be pulled toward the horizontal asymptote. Now, what we don't have is anything for this portion of the graph yet. So that's where number 6 comes in, and we just need to pick a value to help us out. So I'm going to take f at 5, and if I put 5 into this function, okay, I get 2 over 5 minus 4, right, which is 2. So here at 5, it's equal to 2. Now, using the same logic that we pieced the other one together, as we get closer to the vertical asymptote, it has to go to infinity, and we know that we can't cross the x-axis, so it has to look like that. Okay? Alright, next one, a little more difficult one. Here. Again, we're going to start off by finding our y-intercept. Okay? Our y-intercept, which in this case, g of 0, is going to equal negative 4 over negative 4, which equals 1. So here is our y-intercept. Okay? 2. I'm going to find my zeros, which I can set the whole function equal to 0, but then I'm going to multiply by the denominator, which is just going to leave me with the numerator set equal to 0. So you could just do that. You could set the numerator equal to 0. If I do that and I solve properly here, I'll get x equals plus or minus the square root of 2, which is approximately like 1.41. So we're going to put that in right here and right here. There are my only two zeros. The graph cannot cross the x-axis anywhere else. Okay? Those are the only two places. Third, I find my vertical asymptotes. In this case, I take x squared plus 3x minus 4, and if I factor that, right, x plus 4, x minus 1, and I get x equals negative 4 or 1. So there are my vertical asymptotes. So negative 4 is here. Oops, wow, that was really poor. Let's try that again. Negative 4 and positive 1. Okay. Then I have my horizontal asymptote, which in this case is at 2 because my degrees are the same. And so I take my leading coefficient over my leading coefficient. So this is going to be 2. So here at 2. And again, I always think of it this way. The horizontal asymptote is going to pull the graph towards it on the outsides of the graph. Over here and over here, it's going to get pulled toward that line. Okay? Alright. 5, we need to check, does it cross? Okay, now in this case, we're going to set 2 equal to 2x squared minus 4 all over x squared plus 3x minus 4. Okay? Move down a little bit here. And if I solve this, if I multiply both sides by the denominator, I get this. Then if I start gathering my x's on the same side, those will cancel out. I get 6x equals 4, or x equals 2/3. So what that tells me here is that this function, g of x, at 2/3 equals 2. So that tells me, close down here, that there's a point right here at 2/3. There's 2/3. That's 2. Okay? That's the only place it can cross this horizontal asymptote. That helps me a lot, because here then I know that the graph has to approach negative infinity because it can't go up and cross either the horizontal or the vertical asymptote, and it has to be pulled out that way. Also tells me that the graph has to go like this, and that it's going something like that. Okay? Now the only other place that we don't have information about is right there. So I've just got to take, and this is the last one, I've just got to find something that I can plug in here. If I take negative 5, and if I plug it into the function, and I've already done this, so you end up with 46 over 6, which is not approximately, but it is equal to 7 2/3. Okay? So here at negative 5 is 7 2/3, which is up here somewhere, which is great because that tells me then the graph has to be doing this. Okay? Going towards infinity there. And there's your graph. And that's it for rational functions.